Now let's take a look at some of the sample bots available as part of the Hold'em SDK. In the root of the unzipped SDK folder, there's a sample bots directory, and inside that there's a solution file that you can open in Visual Studio or MonoDevelop and another variety of tools. This solution simply wraps one C# project, and that project contains the source code for the 4 sample bots that are provided by default as part of the SDK. Now I'm going to switch over to Visual Studio, and we're going to take a look at each one of the bots very briefly. The first one we're going to take a look at is the fold bot. The fold bot has very simple logic in that it returns 0 every time. This simply means that if there is no call amount, then it will check, and if the call amount is greater than 0, then it will fold. This bot is not particularly effective when it comes to winning, but it will definitely stay in tournaments for a very long time simply by the fact that it only loses chips when it has the small or the big blind. The next bot we'll take a look at is the call bot. Very similar to the fold bot, this call bot returns a hard-coded value, which is actually dynamically determined by the amount that's in place to call for the current hand. So if there are 0 chips to call, then it will return 0, and if it has to return a call amount that is greater than the number of chips that it already has, it will return the call amount, but it will end up going all in for whatever chips it has left. Otherwise, it will simply return that base call amount and wager that many chips to stay in the hand. The next bot, as you can probably tell, is the raise bot. The raise bot just simply raises every bet it has. So if you have a matchup going on that has 2 raise bots in it, then on the first hand they will both ultimately go all in. This is just the nature of these 2 bots in that they never really take into account the current state of the table. They just simply say, I'm going to raise, raise, raise. And if you just have 2 of them playing off each other, then by the end of the opening of the first hand, they will both be all in. And some other bots might follow them blindly off a cliff. So this is something you might want to account for when you're writing your bot logic. Now the next bot I'm going to take a look at is the conserva bot. The conserva bot is a little more sophisticated in that it actually looks at its own hand to determine whether or not it wants to be part of the current tournament. So we start off, the first thing the conserva bot does is it runs a switch on the stage property of the table. Now the stage is one of 4 values. Stages you can see here. There is the opening, which is the first round of betting, and this is before the community cards are made available. The second round is the flop. That's when the 3 community cards are offered. In the 4th round, you've got the turn, and then finally the last round is the river. So first, second, third, and 4th. Now what we can do here, thanks to a language like C# and most languages support these enumerated switches, is we can say, based on what the current stage is, we're going to perform some logic. Now here we have some logic that says this is what happens if we're in the opening. The flop and the turn have their own logic, and the river has its own logic. Now you can break each one of these out individually, or you can hard code the data, but for folks that are familiar with programming, you'll understand that as soon as it hits this switch statement, it's going to jump to the case that this stage maps to. So on the opening, the first thing that it'll do is it'll take a look at its best hand and determine that the best hand that's been calculated for its current cards, which really is just the 2 private cards since there are no community cards at this point, if it's a pair, then it'll run a random check, and this is just a private random variable that will get a value from 0 to 100, and if that's less than 20, which means there is a 20% chance that this will evaluate to true, it will return the minimum to raise amount. This means that simply if we have a pair, then we say 20% of the time we'll raise just to see what happens. Otherwise we'll call. So the important thing here though is to note that in the event that we have a pair as part of the opening, we will not fold. So we'll always either raise or call, and if either of these result in more chips than we have, then we'll go all in. Now if we don't have a pair and we have a best hand, and that the primary rank, meaning that the rank of the best card we have as part of this hand is a jack or greater, then we'll stay in as well, we'll call. But if we receive a hand that has, let's say, a 9 and a 10, then we'll be folding. And the reason we'll fold is because we break at this point, and the break, if we go all the way down to the bottom, anytime something's not handled inside this switch statement, it's going to end up returning 0. So it'll just simply fold, and we will back out of the hand. Now, after the opening, let's say the betting comes back around to us in the flop or the turn. What we'll do is we actually have the same logic in here for both these hands. Now, by the time we get to the flop, we're using 5 potential cards to make our hand, and in the turn we have 6 potential cards to make our hand. So if the best hand we have is at least 2 pair, once again, we'll randomly determine if we want to raise, which is about a 20% chance. And if we decide not to raise, that'll fall through to this logic and determine if we have at least a pair, then we'll stay in the hand. Now, this, of course, is code that you could just take and customize a little bit more to your liking, or you could throw it out entirely and write your own logic here. But this is some basic information to say that if we get to the point where we are at the flop or the turn, and we do not have at least a pair, what we'll do is we'll end up falling all the way through to the 0, which means we'll either check or fold, depending on if we're being raised. And when we finally get to the river, if we're still in the game by the time we get to the river, we're going to look at our hand and say, if we have at least a straight, then there's a 20% chance we'll raise. Straight's a pretty good hand to have at this stage of the game, but it's not a sure thing. So we will conservatively raise 20% of the time. Finally, if we don't have at least a straight, but we do have at least 3 of a kind, we'll call. And of course, if we don't have at least that 3 of a kind, it's going to return 0 because we fall all the way through, and we'll check or fold depending on the hand in place. Now, there's a good possibility if somebody's raising you this stage of the game, our logic here is to say that they must have better than a 2 pair, so we're probably not going to be able to stay in. But note that this is also designed to be a very conservative bot, so it never explicitly goes all in, and it also doesn't try to become aggressive with bluffing, and it also tries not to call bluffs on other hands. It simply looks at its current state of cards and determines whether or not it wants to stay in. This is not a particularly sophisticated bot, but it's a surprisingly effective bot if you're playing against some of the other hands, or rather against some of the other bots, because it does use some bit of artificial intelligence in order to determine its best path to victory.